Hello everyone, Jake here, and I decided to start making some math videos just for the heck of it. Some of you may or may not know, depending on how you know me, that I tutor math here at the college I study at. And it's mostly been college algebra, though I technically also tutor pre-calculus, but nobody comes for that. So it's been mostly college algebra, which has still been pretty fun to do, I gotta say, for a job. And one of the things I enjoy most is helping others with math. So, and something just went haywire. All this stuff. Okay. So I glitched, but it's all good because I am teaching math now. Okay. I've just decided to make videos about general topics that have come up frequently during my tutoring sessions with fellow college students, and one of them happens to be graph transformations. And it's not too difficult to explain, so hopefully the way I explain it will make sense to you if you guys happen to have problems with graph transformations, which I hope you don't. But if you do, then this video is for you. So first thing I've got here is I've got my XY plot, and the first thing we're going to do is we're going to label the axes, because although it seems trivial, it's actually pretty important. And we're going to have to give ourselves a graph to shift around. We're going to call it, and we're going to use function notation. So if you don't know what function notation is, don't be too intimidated by it. F of x in our case, and for most cases, just means y. And we're going to set this equal to 2 times x. So 2 times x, it's a pretty straightforward type of graph. It's just a line which has a slope of 2 and crosses the y-axis at 0. So I'm going to just attempt here to make this graph using the line tool, which OneNote has but likes to snap to everything, which in this case it didn't do too bad of a job, and that looks pretty good. That looks like a pretty good line there. And I'm going to label this f of x. Oops, I really shouldn't have put that parenthesis there. Let me erase that. Awesome. Okay. So that's f of x, pretty simple enough. First thing we're going to do though is we're going to look at vertical transformations or shifts. And this is probably the easiest of all the transformations to do. If you recall from probably previous math classes or whatever, that the general equation of a line can be represented by y equals mx plus b, where m is the slope and b is the y-intercept, or something similar. And this is going to be the basis of how we understand how to shift things vertically. Because suppose we have b here and it's 0, such as our case here. F of x is 2x, and if we had a plus 0 on the end, then 0 would be b. And as we can see, b is 0, so therefore our f of x, our function, our line here, will cross the y-axis at 0, which we see in our graph. However, if we make b equal to 1, or some other number, we will see that this line will actually cross the y-axis at that point. So let's say we wanted to shift our function f of x here 3 units up. We're going to have to call this something different, so I'm going to call this g of x, which once again is representing the y values, but it's different, so we can kind of distinguish between these two functions. So this is going to be 2x, and since we're shifting it up, we're going to add 3 to it, because that's going to be the y-intercept. So this, we're going to make this one red. So this one's going to cross here on the y-axis, and I missed, or it just decided to not go where I wanted it to. That looks pretty good. Alright, we're going to go with it, and we're going to make it right about like that. We're going to try to grab this point and stretch it down to about there. And this line is g of x. As we can see, it looks like it crosses there at y equals 3. And so therefore we have a new line which is now shifted 3 units up. And all we did is we added 3 to our original function. So there you go. That's basically the basis of graph transformations in the vertical direction. If you wanted to move this line down any number of units, you would simply subtract it. So I'm going to go ahead and make the general statement here. If you're given a function or some equation, f of x, and then you add some number n, this shifts the function of x up n amount of units. On the other hand, if we have some function of x and we subtract n amount of units from it, this shifts the function down n amount of units. Alright, so that's the general statement there. And while we use lines in our example here and use this function, y equals mx plus b as our example, you should be well aware of that there are functions or equations and graphs that are like, say, y equals x squared, where it looks like a parabola. And that's not a line, it's a parabola, it's a curve. But the general statement here stays the same. If you have f of x equals x squared and you want to shift that a unit higher than what it is, all you do is you simply put, here I'll just even write it out for you. Say you have f of x is equal to x squared and you want to shift it up 1 unit, then what do? You just have to write out f of x plus 1. And because as we see in our example here, f of x, or in our general statements here, f of x plus n shifts it up. And then when n equals 1 in our case, it'll shift it up n units. So that's going to equal x squared plus 1. And if you graph that or make a x versus y chart, you will find that at every point on f of x versus f of x plus 1, that every point on f of x plus 1 will be one number higher or greater than f of x. And that's basically all there is to know about vertical transformations. So in the next video we will discuss horizontal transformations. So I will see you then.